Hello, I'm David Collum. As with yesterday, I'm the lead developer on the Tom Toolkit and one of the contributing developers to the CIMA collaboration. Today, as with yesterday, I'm going to be doing the navigating for this demo while my colleague Curtis McCully is going to be narrating.
So thanks again. I'm Curtis McCully, and this is really on behalf of several different groups, both the CIMA group, which is trying to understand how we can get not only just targets to users, but also messages. So say things like the GCN. So in some respects, the hopscotch that Mario had demoed yesterday can be thought of as a broker, but not just a broker for alerts, but brokers for messages and things like that as well. So today I wanted to walk you through kind of an end-to-end workflow of what you might expect, like what an end user could do if there was a gravitational wave event. So, I mean, you start, this gravitational wave is detected, LIGO, Virgo, Kagra are collecting gravitational wave data, and that's great. But what about the electromagnetic counterpart? If you were part of the original Kilonova search, you understand that how chaotic that could get. So we have set up a system for, say, our Tom that sends us text messages whenever there's a gravitational wave event. And so you can do, people can do something similar, but basically you find out about the event somewhere. So what happens next? Well, the first thing we want to do is we can go to the CIMA database and start looking at some information about the event itself. So Dave, if you want to go ahead and do that. So in the Tom Toolkit, we have this this broker module with CIMA, and so we're going to search for this specific event. And here are some of the follow-up detections. So there's a lot of things we can already look at from here. So one of which might do is just go look at the GraceDB page for this particular target. So let's go see if we can do that. Great. And so, we can go look at the probability regions, which is already nicely provided by LIGO. This is a reasonably well localized one for the high probability section, but to get up to 90% confidence, the region's very, very large. And so one thing your users might want to know is, what's the area of this event? Do I have enough telescopes or resources to cover this well? What galaxies are there, things like that. And so this kind of gives you a first start to just understand what the gravitational wave event looks like at itself. Now, if we go back, we can start looking at some of these individual sources. So these sources that are listed here were all ingested from Swift. So these are Swift X-ray sources for this particular event, with some of the comments in the right-hand column, along with coordinates and things like that. Now, let's say we pick one of these that looks interesting. Yeah, maybe. So go ahead and just pick one. And then from this, we can create a target in our local Tom. Now, one of the nice things about this is we no longer have to continually query the brokers anymore. We now have a local copy of this, so we can keep track of what's going on. Now, once we've got this page, there's several things we can see. It's got a small snapshot, it's got the coordinates, and we can also start thinking about if we want to submit observations for this particular target. So if we click on LCO, for example, we can go look at the LCO pages and we can see, okay, it's got decent visibility in the south. And so if we wanted to submit an observation of this, we could very quickly. So, we'd give it a name and maybe an exposure time and a filter. And from there, with just a few clicks, you can get an entire observations sequence set up. Now, here we are just using the plain Tom Toolkit version of the observing form. In practice, you would want to customize this form so all of this would be pre-filled. And so instead of 10 clicks to submit this observation, it would be one click to say, okay, this looks like an interesting target. Let's go get a Floyd spectrum, or let's go get images of this event. All right, and there we go. So we now have an observation that's in the LCO portal. And we'll cancel this in just a minute, but this is a real observation that is now pending. So we've gone now from looking at targets that were submitted via GCNs which were then ingested into SIMA. And then we use the SIMA database to create a target in our local TOM. And then we've now triggered an observation on this object. All right. So let's go back. And what if we wanted a different type of target? Say we wanted to go query for ZTF or something like that. So now we're going to go to LSSTC, and we can set up an automated query based on LSSTC's API, and we can search for targets in this particular region. This particular object's in the south, so we've had to fake this one. So if we just go to targets, we can go down and we can pull up one that was ingested earlier. So now that we've got this object in the queue, we can then maybe use a different AEON facility this time. So instead of LCO, we can click on Gemini.
Just a disclaimer, I actually am not sure that this is going to load the Gemini form. Actually, yes, but we can't submit a real observation right now because we don't have time for this demonstration, Tom.
Which is probably good. We don't really want to slew an 8-10 meter telescope, just kind of willy-nilly for a demo. But in principle, you fill out, this form, and in SNCS 2, which you'll hear about tomorrow, we've got a lot of these pre-populated so that it's even faster to go from choosing a target to submitting a spectrum on Gemini. So all these things just can streamline the whole process, going from information that's coming out of other surveys like ZTF or SWIFT or anything like that, and then getting more follow-up observations on that. Now, finally, one of the things I want to show you is, say we did now get this observation from Las Cumbres. Now, one of the things we got to do is, how do we get this information back out to the rest of the community? Now, to do that, we've implemented this button up here, which says submit back to SIMA. And if we click that button, it will then go ahead and show that. It will then send an alert back through HOP, which is what Mario showed. And, you can automatically produce a GCN, or you can have some other type of message. But there's some other message that we have now pushed back to the community to say, we have observed this. In principle, we could put a classification in this. We could put magnitudes. We could put some kind of information that other systems, other listeners to this stream would be able to then use as they're planning their future, their upcoming observations, things like that. So I think brokers are really going to play an integral role in multi-messenger astronomy. And right now there's several different ways to look at all these, and you have to go to several different places to get all the information. So one of the things we're trying to do also as SIMA is start to synthesize these. And so we've got a bit of a mock-up of synthesizing some of the data between these different sources. And I don't know if you want to show that real quick.
Yeah, just give me 1 second. I did not have that prepared.
Sorry.
2 minutes. You have 2 minutes.
Great. But there's a very, there we go. So a lot of this information can be pulled from multiple sources. And because of how all the brokers and all these different information sources are starting to build APIs, it becomes a really powerful thing that we can synthesize all this data together. And so, this is kind of a mock-up of this particular event. All right, what do we know about the gravitational waves? What do we know about the sky localization? What do we know about other people's tilings from the treasure map, which Andy will talk a little bit about tomorrow. And so, but with the development of brokers and APIs, we're really changing how we think about observations and how we really do, gravitational wave and MMA science in general. So with that, thank you.
Thank you. So I don't see any question in the Slack channel, but if someone has a question, please ask. Okay, if not, we are finishing this session.